Good morning. So, unfortunately, I did have to take me out today. I'm home again with sick kids. But of course, you can still do math because I can help you work through this packet just as I'm right here next to you. So let's get started right away. Which table of values represents a function? Number one. Now, you have to, the very most minimum thing you have to know from this unit is what is a function. And in order for something to be a function, each x must have only one y. So we can't have our x's repeat if we're looking at a table or a list of coordinate pairs. So if I take a look at my first table, 4, 5, 6, 7, no repeating x's. My second table, 1, 2, 3, 1. There's a repeater. That is not a function. Number 3, 2, 2, 2, 2, 2, 2. Lots of repeating 2s, not a function. And 4, 2, 3, 2, 4, repeating 2s, not a function. So the only one that fits the definition of a function is 1. Notice each y value is 1. That's okay. Your y values can repeat. Y values can have more than one input. It's just that your input can only have one output. Which brings me to the next question, is this relation a function? And now we're looking at it from a mapping. So these are your x's, your inputs, these are your y's, your outputs. So we want to make sure that each of our inputs only maps to one output. -1 maps to 25, that's okay. And here's our issue. 2 is mapped to 3 and to 25, so that makes it not a function. Explanation is right here. It is not a function because an input, 2, has more than one output, 3 and 25. All right, moving on to number 3, where we're going to be evaluating functions. I started some of these for us so that I could kind of just go through and show you. If I've replaced the x in f of x, like here, instead of f of x, it says f of negative 2. I replaced the x, so you're going to replace the x in the rule. And we're going to do 5 times negative 2 minus 3, which gives me negative 10 minus 3, which gives me negative 13. Now, if I go too fast here, you can always pause it, copy what's on the screen, or try to do it on your own, and then you can replay it if you need to hear or see it again. Okay. Part C, f of 2/5. Again, we replaced x with 2/5, so I replaced x with 2/5 in the rule. 5 times 2/5 minus 3. Just a little reminder here, 5 times 2/5, we can divide each of these 5s by 1 by itself, leaving us with 1, which gives us just 2 minus 3, which gives me negative 1. All right, now we're going to evaluate f of 10, and whatever we get for that, we're just going to add 3 to it. Looks like this. Here's where we're evaluating f of 10. Here's our plus 3. F of 10 gives me 47 plus 3, and my answer is 50. All right, now here's the ones we love, a function in a function. D says that g of x is 2 times f of x minus 1. So if we want to find g of negative 5, we first need to find f of negative 5. So I'm going to do that over here. I'm going to take this and evaluate, or actually, boop. I'm going to take this and just evaluate it over here. So f of negative 5, and we're using this function again, f of negative 5 equals 5 times negative 5 minus 3. And that's negative 25 minus 3, which is negative 28. Now, I replace this f of negative 5 with negative 28 because that's what f of negative 5 equals. So you just throw that right in there. And you get g of negative 5 is going to equal 2 times negative 28 minus 1. Now, I don't have my answer key in front of me, so let's see if I can impress you with my math skills. 2 times negative 28 is negative 56. Minus 1 is negative 57. You will see a question like this on the test tomorrow. All right, now number 4, another favorite of ours. It says, given g of x equals negative 3x plus 2, find the input value. Find the what? Find the input value. What's your input value? X, 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 x. Find x when g of x equals 41. Do I say here x equals 41? No. It says g of x equals 41. Do not substitute 41 in for x. You're going to substitute 41 in for g of x. So it's going to look like this. And now you just solve. Subtract 2, subtract 2. 41 minus 2 is 39. Equals negative 3x. Divide by negative 3, divide by negative 3. And you get x equals negative 13. You could have also typed into your calculator, into y equals, you could have typed y1 equals our negative 3x plus 2. And then gone to your table by hitting second graph and looking for where y1 is 41 and getting the x value of negative 13 from that table. All right, on the next page, I think I'm going to talk about this using the graphing calculator. So what you can do is, we've got two different functions here. To make your life easy, I would type the f of x function into y1, and then the g of x function into y2. Now, if you're looking for y values, just remember, if it's f of x, you're going to look at the y1 column, and if it's g of x, you're going to look at the y2 column. All right, so f of negative 1. You could do it by hand, just like I have here, 4 times negative 1 minus 3. Or you can look for where x is negative 1 and look for what the y1 value is there. And when x is negative 1, your y1 value should be negative 7. I'm going to skip b because I'm going to stick with all my f functions now, so I don't have to change my color. All right, so then f of 1/2. Now this one would be tricky to see on your calculator. I did show you how to change the table, but since this isn't a very difficult function to work out, I would probably just do this one by hand. 4 times 1/2 minus 3. Or type it into your calculator like that. 4 times 1/2 minus 3. Anyways, 4 times 1/2 is 2. And 2 minus 3 is negative 1. All right, next is 3 times f of 4. So first you got to figure out what your f of 4 is. I'm going to do it differently. And then multiply that by 3. All right, so f of 4. Again, we're going to go to the table, second graph, look for where x is 4, and look at what the y value is at that point. And the y value at that point should be 13. The y1 value. And then we multiply by 3. 3 times 13 is 39. All right, let's move on to our g function, which we're going to look at the y2 column for. So g of 3, if you were to work it out, would be 3 squared plus 2 times 3 plus 1. But if you just look at where x is 3 and look over to y2, what you should see is 9, 16. All right, now I'm going to skip to f, and you could work it out by evaluating what g of negative 3 is, by working that out and then squaring it, since it's g of negative 3 squared. Or you could just use your calculator. When x is negative 3, what does the y2 column say? What is g of negative 3? Then we have to square it. Well, what do we get? 3 plus 1 is 4. We end up getting 4. And 4 squared is 16. Okay, continuing with evaluating functions. Let's take a look here. G of 4. You're going to substitute 4 everywhere you see x. 4 squared minus 4 divided by 4. And the answer there is 3. How about the next one? Negative 4 squared. That would be negative 4 squared, and be so careful, you will see this on the test tomorrow. Squaring a negative, put it in parentheses. Negative 4 squared is positive 16, and then minus this negative 4 is plus 4. So that's 16 plus 4 is 20, and 20 divided by 4 gives us 5. G of 1 is 1 squared minus 1 divided by 4. 1 squared is 1, 1 minus 1 is 0, and 0 divided by 4 is 0. And then G of 2 is 2 squared minus 2 divided by 4. 2 squared is 4, 4 minus 2 is 2, and 2 over 4 equals 1/2. All right, one more function in a function. So now we're going to use that g of x function to help us find h of x. H of 4 would be 1/3 times g of 4. So we've got to first figure out what g of 4 is. And actually, we don't need to figure it out. We did already, right here. G of 4 was 3. So what goes in those parentheses there? 3. And what's 1/3 of 3? 1. So h of 4 equals 1. All right, this is a great spot to pause this screencast so I don't get cut off and do another one to finish the pack.